Alright, Wolfie, I thought I'd make a video. Well, for starters, they say it's 10,144 kilometres to Cape Town from Adelaide. So if we were using a litre a kilometre, we would need at least around 13,000 litres. If we were using 2 litres a kilometre, we'd want around 26,000 litres of fuel just to make the journey. What people see, my thought on how relativity works is you are always constantly still. The only reason when you walk, all you're feeling is electrical signals to make you think that you're actually moving. You think that the earth is stationary and you're moving on the earth like this. Well, that's where I see it differently. I feel it like how in the song says it, you feel the earth move from under your feet. So basically you are stationary. You might be walking with your feet, or you're flying with a plane, or driving in your car, but the pen is stationary and the earth moves under your feet. So you're basically staying in the same position. It's just that you're feeling electrical signals like in your movement of your legs, and you're feeling those signals to think that you're actually moving. Same with a jet engine. You're feeling the acceleration, which is just electrical signals that your body determines. You're hearing sound waves, which is electrical signals. That's all it is electrical signals. North is negative, south is positive. And determining on which direction you're traveling determines on the pull or the push, like how a magnetic field works. Same with west to east. West is negative, east is positive, because that's the direction energy flows. Energy flows from north to south. You look at all the water currents on the earth, they flow from north to the southern hemisphere. That's how all currents, electric currents, water currents flow on the plane. Same with from west to east in the equator. But for my map, like I was saying, you think that you're moving from here out. But if I hold this pen still, okay, we'll get it so we're in Australia and we are down this magnetic field line, okay, which is from north to south. We're basically stationary here. In South Australia, I would travel directly west, because this is south, this is north. Directly west is, I'd actually go a little bit northwest, because if I went too far southwest, I'd actually miss Cape Town and fly past it. So if I make sure we're going a little bit northwest, then therefore we'll make landfall. So if I keep this pen here and I start moving to the northwest, what do you think happens? The pen's not moving. It's just that we found Cape Town and we stayed in the exact same position. We haven't moved. The earth moved under our feet. That's because the motion of our legs interpret from the electrical signals, think that we're actually moving, when theoretically we're actually stationary and everything else is moving. It's like when you play a video game or a simulator, you can see in the plane simulator, if you're outside the simulator watching, the plane's not moving. The ground's moving from underneath their feet. And when you're in that simulation, if you're in that game that you're watching from outside the screen, you'd feel like you're flying. You feel like you're moving. But you're watching it from outside the screen, nothing's moving. The people in the simulator aren't moving. The actual ground's moving. It's the same with in this life. If you go and jump into a simulator, you think you're flying the plane, the simulator's moving, and you're getting all the motions and all of that, the electrical signals. But in reality, you're sitting in a cabin, and the cabin is moving, and the ground is moving. But it's simulating what you feel in this reality. And I just explained it exactly how, not only that, if we keep the pen there and we keep going, we'll actually go to South America. And if we keep going, we'll go all the way back around the world. You can only see, in reality, less than this circle down that line. we're seeing about 5,000 kilometers in this little circle. Okay, this little circle represents about 5,000 kilometers of the Earth, which is nowhere near that. And I just explained how you can go around the world by a simulation. It's very simple, it's very easy. You can build a computer game based on this, which would replicate Earth as a flat Earth, and it's in 5 dimensions. I've got to make another video on how we live in 5 dimensions, but that's another thing. That's basic how it can work. We're always down this line. We're always from the positive to the negative, the magnetic field. Plain and simple. It can work. I could build this in a computer program and design it exactly like this, and it will work. It's not rocket science, man. Anyway, thanks for watching.